Hi everyone, I'm Eleanor from the KU Natural History Museum, and I'm so glad to be back with you all for Pop-Up Science Online. Today, we'll be investigating ice. And if you live in the Midwest like I do, then you've probably seen a lot of ice and snow lately, thanks to the polar vortex that's been bringing frigid temperatures from the North Pole down into the lower US, including even southern states like Texas. In today's program, we'll explore the science of ice, and then we'll try out a couple of fun ice experiments. For step-by-step instructions for today's activities, head to our Museum from Home webpage and click on the Pop-Up Science tab, where you can find a downloadable PDF with all the instructions. As you probably know, the solid form of water is called ice. Ice is created when the temperature of water falls to or below 32 degrees Fahrenheit, which is the same as 0 degrees Celsius, and it freezes. Our kitchen freezer isn't the only place where you can find ice. Ice is found all over the world. There are icebergs, which are large pieces of ice in the ocean, and on land, there can be anything from small icicles to large glaciers, which are massive accumulations of ice that form in places where there's lots of snow. When lakes freeze, they become a hard, slippery surface called shelf ice. There are also different types of ice-related precipitation, such as snowflakes, sleet, and hail. Ice is everywhere. In terms of the science of ice, let's first refresh our memories on some basic principles. All objects, organisms, anything that has mass and takes up space is made up of matter. And matter can exist in several different phases, such as solid, liquid, and gas. Matter can change from one phase to another when physical conditions change, like when energy, such as heat, is added or removed. Most of the time when we discuss water, we think of it in its liquid form. But when water is exposed to cold temperatures at or below 32 degrees Fahrenheit, it freezes and becomes that solid we call ice. It's important to remember that despite the change in its phase, the substance stays the same chemically. It's still water, which is H2O, 2 hydrogen atoms bonded with 1 oxygen atom. So liquid water, ice, and even gaseous water vapor are 3 different phases, but the chemical composition stays the same. But how does liquid water turn into solid ice? Well, it all centers around the fact that ice is technically a mineral. We tend to think of minerals as earth materials like quartz and pyrite, things like that, but ice is a mineral too. If you watched my pop-up science episode on rocks and minerals back in May of 2020, then you'll recall we learned that the definition of a mineral is a naturally occurring solid with a unique chemical formula and crystal structure. Ice occurs naturally on Earth, has the chemical formula H2O, and forms hexagonal crystal structures. So it's a mineral. In order for ice crystals to form, just like with any other mineral crystal, it starts with a process called nucleation. Nucleation takes place when the molecules in a liquid start to gather into tiny clusters, arranging and stacking into a crystal structure. This process requires a nucleation site where the very first crystal begins to form. Typically, ice nucleation is kick-started by impurities in the water, such as tiny specks of dust or dirt. When there aren't any impurities in the water, like in the case of purified bottled water, then the water can reach a temperature below freezing point without turning into ice. Let's check out this phenomenon for ourselves. For this activity, you'll need a clear plastic bottle filled with purified water, a freezer, and a table, desk, or a countertop. To start, we'll put the plastic water bottle in the freezer and we'll place the bottle on its side. Then we have to wait, approximately 2.5 to 3 hours. Depending on the size, thickness, and shape of your clear plastic bottle, you may need to wait a little bit longer. After the appropriate amount of time has gone by, carefully and slowly remove the bottle from the freezer and do not shake it. The water inside the bottle should still be liquid, but very, very cold. This water is supercooled, meaning that it has reached a temperature below freezing without turning into solid ice. Now, I will note that this particular experiment is quite difficult to pull off successfully. You'll probably have to try it again and again in order to make it work. I certainly had a lot of trouble with it myself, and I think that it's because the plastic bottles that I was using had some little indentations and things that essentially created nucleation sites. So I wasn't able to get it to work, but I'm going to show you a short video of someone who did get it to work. Then hit the bottom of the supercooled water bottle against your table or desk or countertop. Whoa! How cool is that? The water froze instantly. What we witnessed when this happened was nucleation. Since the purified water didn't have any impurities in it, it didn't turn into ice in the freezer. Instead, we kick-started the ice nucleation process by whacking the bottle against the counter. We can also try another fun instant ice experiment. And we need the following things for this activity. Again, you need a clear plastic bottle filled with purified water. Then you'll also need a clear plastic party cup or a small bowl, several ice cubes, and towels for easy cleanup. Following the same procedure as before, we'll put the water bottle in the freezer on its side for about 2.5 to 3 hours. Before you take the water bottle out of the freezer, put several ice cubes into the party cup or small bowl. Then carefully remove the water bottle and very, very gently open the cap, trying not to shake or jiggle it. Slowly pour the supercooled water over top of the ice cubes. Wow! An ice stalagmite! Upon contact with the ice cubes, the supercooled water instantly froze into a stalagmite structure. How tall can you make yours before it topples over? In case you're wondering what the word stalagmite means, a stalagmite is a naturally occurring tapering column that grows up from the floor of a cave. Stalagmites form when groundwater drips into the cave, and they are usually made up of things like calcium carbonate or other minerals, but ice stalagmites can also grow in caves. In our case, the ice cubes in the bowl acted as a nucleation point for the supercooled purified water. Since the ice cubes are already crystallized, when the liquid water hit the ice cubes, the water immediately transformed into more ice crystals upon touching the existing ones. This process acts almost like a chain reaction where more and more water freezes on top. Ice is very fascinating for scientists because it occurs in 16 or more different forms in the universe. The different forms are classified by their density. Density is how you measure how solid something is. It's the object's mass per unit volume. Each type of ice reacts a certain way when exposed to different pressures and temperatures. The form of ice that we get here on Earth, scientists call Ice 1 or Ice H, where the H refers to its hexagonal crystal structure. Temperatures and pressures at Earth's surface don't vary that much, so Ice H is the only form of ice on our planet. But on other planets and asteroids and other celestial bodies out in space, where temperatures and pressures can be higher or lower than what's here on Earth, liquid water, ice, and water vapor can stabilize at different points. Therefore, ice can form into different shapes, like in the case of Ice 7, which forms tiny rod-like needles. Ice 7 is associated with planetary collisions in space, and planetary geologists think Ice 7 exists on Europa, which is one of Jupiter's moons. Well, I hope that I've piqued your interest in ice today and that you've learned something new. And I also hope that you had a lot of fun trying out those different instant ice experiments. We'd love to see how your ice stalagmites turned out, so please feel free to post pictures either in the comments or by tagging the museum on social media. Thanks for joining me today, and be sure to tune in next month on March 20th to learn about different bird beak adaptations. Bye-bye!